The big advantage for single-wall nanotubes is really their shape. I mean, graphene is conductive, single-wall nanotubes are conductive. Graphene is strong, single-wall nanotubes are strong. But what graphene cannot do and will never be able to do is there are many applications where you want the nanomaterial to be able to entangle. And that just means to sort of wrap around each other so that if you have networks, they really tie themselves, the nanotubes tie themselves together really, really well. That can never happen with graphene. It can never happen with zero-dimensional nanomaterials. It's something that only one-dimensional nanomaterials can do. And from one-dimensional nanomaterials, single-wall nanotubes are by far the best. They have the best combination of strength and mechanical properties. So they really are a unique material that have many advantages over other nanomaterials. Well, I mean, lithium-ion batteries are very important for many reasons, for cars, for energy storage from renewable energy sources, etc. So it's really important to improve them. And that really, for most people, for nanotubes, that means making batteries more conductive. But there is another reason, and that is really making the battery electrodes better mechanically. Now, graphene, carbon black, any conductive nanomaterial can make batteries more conductive, but only single-wall nanotubes, or only nanotubes, one-dimensional nanomaterials, can make them mechanically stronger. And the reason for that is that the nanotubes can wrap around each other. Graphene sheets, they tend to slide past each other. When you put them into a graphene battery material, they don't make it stronger, they only make it more conductive. And that's really a limitation of all other two-dimensional materials, all other two and zero-dimensional materials. One-dimensional materials are multifunctional in that they can improve the electrical and the mechanical properties of batteries. And that's it's a very important thing, because that, in my opinion, is going to be the key to really developing the next round of batteries. This is a great meeting from my perspective, because there is really great science and engineering being discussed, but importantly for me, there's a very large number of industry people here who really know about the problems and the challenges associated with composites for structural materials or for energy. And as an academic, it's being able to talk to those industry people that really allows you to frame the next set of problems and understand what you need to be working on. So this summit is brilliant from that perspective.